Hello, welcome back to the channel. I am Pat at Maendeleolab, and today is the second topic of 7, and we are building a standard infrastructure. So this is the graphical design. This is what we will be building for this topic. We are going to build 4 VPCs. We will deploy inside those VPCs. We will have the public subnets, private subnets, public route tables, and private route tables. We are also going to establish a VPC peering between both of our customers' VPCs for the public subnets. We will deploy the internet gateways for both customer VPCs, including the egress VPC. We are also going to deploy prefix lists, security groups. We will create the NAT gateways and elastic IPs. I believe that is basically everything that we need to cover in order to build this infrastructure. So here we are. This is the command line. I'm running this from the command line. As you can see, I'm using a Python script, which I will talk about during the wrap-up. We'll go over some of the code. We'll go over how I come up with it, and all those details will be covered in topic number 7. But for now, let's launch this. I'm using a timer. So let's go quickly over to the console to see what's really going to take place. As you can see now, before I started to run my script, this is just a default VPC, default subnets, route tables. Everything here is really for the default VPC. I'm going to refresh to see where we stand. You can see right now we've already created the 4 VPCs. As you can see there, let me change this a little bit. Yes. So we do have customer VPC number 1, number 2. We have the egress VPC built, and we have the inspection VPC built as well. Now let's check the subnets. Starting with customer VPC number 1. As you can see, we've created 2 private subnets and 2 public subnets, each in a separate availability zone, 1A and 1B. Now, this is the customer VPC number 2. As you can see, it's the same private, public, and each of the subnets are associated to an availability zone. That's what I meant to say. This is the egress VPC. As you can see, same. We have private and public subnets, and they each using a separate availability zone. Leads us to the last VPC. This is the inspection VPC. We have 2 subnets for the AWS network firewall interfaces and 2 subnets for the transit gateway. As you can see, 1 in each of the availability zones, 1A and 1B. Now we going over to the route tables. For customer VPC number 1, we only have 2 route tables. One is for the private subnets, and the second one's for the public subnets. As you can see, we have explicitly associated the subnets to the route table. And now this is the same for customer VPC number 2, same setup. For the egress VPC, you can see we do have a private subnet in each of the availability zones, and then we only have one route table. So this is interesting because we are creating 2 NAT gateways, and we are placing each of the NAT gateways in each of the private subnets. Then what they do is, after they've been created, we do assign an elastic IP to each of the NAT gateways, which then uses the public route table to forward traffic to the internet. So that is the traffic pattern, and this is why we have 2 private route tables and only 1 public route table. And now this is the inspection VPC. Inspection VPC, I will go over the details when we create the AWS network firewall. But just quickly, this we have a route table dedicated to the AWS network firewall interfaces or subnets. In these subnets, this is when we deploy the AWS network firewall. The interfaces will be assigned to these subnets. And this route table will have a route pointing to the transit gateway. And here we have 2 route tables, one for availability zone A and the other for B. And each of the route table has an explicit subnet associated with it. And that is for the transit gateway to forward traffic to each of the AWS network firewall interfaces. So this is really important because a lot of times this is the connection that needs to be correctly done to allow that traffic to be forwarded to the firewall and sent back to the transit gateway. Internet gateways, we've created 3 more, 2 for our customer VPCs and 1 for the egress VPC. So there's no need for us for the egress, no need for carriers, and no need to tamper with DHCP options set. We'll skip over to elastic IPs. Elastic IPs. With the elastic IPs, these are the 2 allocations that we created. One will be for the NAT gateway inside availability zone 1A, the second one for the other NAT gateway in availability zone 1B. If I bring you back to the drawing, I think we need to add this. Here we go. So if you come back to the drawing, we created the egress VPC. We have NAT gateways in each of the private subnets, but also they do have an elastic IP assigned to the NAT gateways. And these NAT gateways will forward traffic to the internet gateway to get to the internet. The very next set, I'm going to filter these. This is our managed prefix list. This is one of my favorite features as well. What it does, I'm a big fan of simplicity. Why do 3 or 4 things when I can only do it once, right? And this is the managed prefix list. The way it works, you just basically create a prefix list. And in this prefix list, you're going to have entries. Those entries can be route entries for specific destinations or sources. But we can list all of our entries here, and we can reference this prefix list in a security group or in a route table. And imagine, let's say we have more than 20 route tables that we need to add those route entries to. instead of going to all 20 and having to add a specific route entry, instead, we can come here to this prefix list, add the additional route entry, and that will get propagated to everywhere where we have the prefix list referenced. So this makes life a whole lot easier as your infrastructure grows. It just keeps it simple for you. So this is why it is one of my favorite, and this is why I use it a lot. So in our case, we have route entries for customer VPC number 1 public. These are the public subnets for customer VPC number 1. And we have the private subnets for customer VPC number 1. If we go back to our design, you can see the privates, they do have the 8 and 9 network. And the public do have 1 and 2. We can quickly check to see if we have everything we need. This is VPC 2, it's there. Let's look at the egress. Okay, we didn't have anything specific for egress, which is great. See, I don't think we do have anything for inspection as well. Doubt it, great. So prefix list was really specific to our customer VPCs. We don't have any endpoints in this particular use case, no endpoint services, but we do have NAT gateways. As you can see, they're right there. They were created for availability zone 1A and B. The peering connection was established. As you can see, it's established between the 2 VPCs. We do not, in my opinion, really try not to use the network ACLs unless you really have to. But in my case, I'm using security groups. We do have security groups that we created from the script. This is for network dev 1. And we have security groups for network dev 2 as well. I believe this is everything that we needed to create from an infrastructure perspective. If I come back to our terminal, you can see the script ran for 5 minutes and 12 seconds and created all of those resources that we just checked in the console. So quick wrap up of what we just did. We built the standard infrastructure. We deployed VPCs, subnets, route tables, prefix list, security groups, NAT gateways, internet gateways, and we established a VPC peering. So this is it for today's topic, which is the second one of 7. The very next topic, we will deploy the EC2 instances. We will need those eventually for us to do the network performance test, which will happen further down in topic number 6. I hope you find this informative. If I missed anything, if something wasn't clear enough, please drop a comment. I can always do another version of this. No problem doing that. But I hope that this is interesting and hopefully is adding some value to some of the things that you are working on. I am Pat at Maendeleolab. Until next time, less research and less develop. See you next time. Thank you.